Hello and greetings to everyone. We move to our next lesson, which is standard form. Standard form. When we talk of standard form, we are simply referring to an easy way of writing very large or very small numbers. Most often in mathematics, it is very difficult for us to perform calculations while handling very large or very small numbers. Let's take this down. It is very difficult to handle very large or very small numbers when performing calculations. To reduce the risk of making errors or the stress of writing very long numbers, we express the number or numbers in standard form. That is, in the form write with a red pen a times 10 to the power n, where one is less than or equal to a, strictly less than 10, and n belongs to the set of integers. It means n is either a positive or a negative integer. Take this down note. To express a number in standard form, put a decimal point after the first non-zero digit and find the correct power of 10 by this 10 by either counting to the left in bracket If you count to the left, then the power of 10 is negative powers, or counting to the right. If you count to the right, the power is positive, in bracket positive powers. Close the bracket, the number of digits after the decimal point. We take down these examples. It goes express the following numbers in standard form. Here we have the number 1,700,000. For B, we have the number 0.00004751. For question E, we take the given number 1,700,000 in standard form. It is simply equal to, remember I gave a note which says that to express a number in standard form, put a decimal point after the first known zero digit. When you put the decimal point after the first known zero digit, this will simply help us in getting this our A and the power of n when we count the number of digits, either moving to the left or moving to the right. For this our number, 1 is the first known zero digit. We are going to fix a decimal point after 1, and this will give us 1.7. Since after 7 all the other digits are zeros, we are going to discard them, times, then we need the power of 10. We are going to count the number of digits after the decimal point, which is fixed. After the first known zero digit, we have 7, which is the first one. 1, 2, 3, 4, 5, 6. In this case, we are counting to the right, and counting to the right gives us a positive power, times 10 to the power 6. Therefore, the number 1,700,000 in standard form is simply 1.7 times 10 to the power 6. Underline the answer. We move now to question B. We have the number 0.00047551 in standard form. It will simply be equal to, we are going to fix a decimal point after the first known zero digit of this number. This 4 is the first known zero digit. We are going to fix a decimal point here. Fixing a decimal point here simply means our A will be 4.751. We must write the 4 with all these other digits following. And you'll see, like for example, in the first case, 1.7, it lies between 1 and 10. In this case, number 4.751 lies between 1 and 10. We are going to multiply this by 10. Next, we have to get the power of 10. In this case, you'll see that we will be counting the number of digits after the decimal point to this direction, not to the right. you take note, we'll be counting to this direction where we have our first decimal point. We are going to count, we have 1, 2, 3, 4, 5. In this case, we are counting to the left. It simply means the power will be negative. Remember, counting to the left gives a negative power. Counting to the right gives a positive power. Therefore, the number 0.00004751 in standard form is 4.751 times 10 to the power negative 5. You must take note of this. The reason why our A, this A, remember, when writing expressing a number in standard form, that is A times 10 to the power n, with A lying between 1 and 10. The reason why A cannot be 10 is simply because, let's take a case where A is 10, that is 10 times 10 to the power n. This will simply be equal to 10 raised to the power, applying the laws of indices, this will give us 10 raised to the power n plus 1. In 10 raised to the power n plus 1, our A is absent, and this number is not in standard form. It is not of this form. That's why our A must be different from the number 10. You take note of this. We move now to the next heading, which is manipulation of numbers in standard form. Manipulation of numbers in standard form. Take this down. Given two numbers in standard form, that is, we take A times 10 to the power n and B times 10 to the power m. For 1 less than or equal to A, B2 strictly less than 10, simply means A and B, they lie between 1 and 10, and n, m belongs to the set of integers. We have the following. For the first one, I, we multiply the two numbers in standard form. This will simply be equal to, we are going to multiply A and B, A times B times 10 to the power n times 10 to the power m. And this will simply be equal to A times B gives us AB times 10 raised to the power. Multiplying these two numbers in index form, we are going to add their powers, times 10 raised to the power n plus m. If we take this down, if AB, this is our AB, this product is greater than or equal to 10, then express the number AB in standard form. When you express it in standard form, then you place it here. Then you simplify the numbers with 10 raised to a certain power by applying the laws of indices. Take the next one, 2i for division, dividing a times 10 to the power n by b times 10 to the power m. This will simply be the same as a times 10 to the power n all over b times 10 to the power m, which is simply equal to a over b times 10 raised to the power n minus m. We subtract the powers. If we take this down, if the quotient a over b is greater than or equal to 10, or if the quotient lies between 0 and 1, exclusive, then express the quotient, express number a over b in standard form. After expressing in standard form, we are going to replace it here. Then we simplify the tens raised to a certain power. Let's take these examples. Evaluate the following, leaving your answer in standard form. For the first question, E, we have 3 times 10 to the power 3 times 4 times 10 to the power 4. Question B, we have 3 times 10 to the power 10 divided by 2 times 10 to the power 7. Take solution. For question A, 3 times 10 to the power 3 times 4 times 10 to the power 4 is simply equal to, we take 3 times 4 times 10 raised to the power 3 times 10 raised to the power 4. This will simply be equal to 3 times 4 gives us 12 times 10 raised to the power 3 plus 4, which is 7. You will see that the number 12 is out of that range for the values of E. 12 is greater than 10. We need to express the number 12 in standard form. Expressing the number 12 in standard form, write down the number. We fix our decimal point after the first non-zero digit. We multiply by 10 raised to the power. We count the number of digits to the right hand side. We have just one digit, times 10 raised to the power 1 times 10 raised to the power 7. This will simply be equal to 1.2 times 10 raised to the power, we are going to add the powers, 1 plus 7, which gives us 8. Therefore, 3 times 10 to the power 3 times 4 times 10 to the power 4 is simply equal to 1.2 times 10 to the power 8 in standard form. We go to question B. For b, we have 3 times 10 to the power 10 divided by 2 times 10 to the power 7. This will simply be equal to, you can express this as such, 3 times 10 to the power 10 all over 2 times 10 to the power 7. This will simply be equal to 3 divided by 2 times 10 raised to the power 10 minus 7. This will simply be equal to 3 divided by 2 gives us 1.5, which lies between 1 and 10, times 10 raised to the power 10 minus 7 gives us 3. 1.5 times 10 to the power 3 is in standard form. We underline our final answer. Therefore, 3 times 10 to the power 10 divided by 2 times 10 to the power 7 is simply equal to 1.5 times 10 to the power 3. We are going to end by taking down the exercises for application on standard forms. Exercises for application. Question 1 equals write the following numbers in standard form. A, we have the number 4,600,000. B, we have the number 0.0000050241. For question C, we have the number 12 billion. And lastly, for question D, we have the number 0.00000000. There are 10 zeros after the decimal point. 5, 8, 7, 3, 2. We go now to question 2, which says find the following products, leaving your answer in standard form. For E, we have 5 times 10 to the power 12, all these times 6.5 times 10 to the power negative 9. For B, we have 4 times 10 to the power negative 9 times 2.6 times 10 to the power 14. We go now to question 3, which says find the following quotients leaving your answer in standard form. For E, we have 7 times 10 to the power 7 divided by 3.5 times 10 to the power -5. For B, we have 8.4 times 10 to the power 9 all over 6 times 10 to the power 5. We go now to question 4. Question 4 says by expressing the numbers 0.00036, 756,000, 1,800 and 800 in standard form, evaluate 0.00036 times 756,000 all over 1,800 times 800 and give your answer for question E in standard form. For question B, to 2 decimal places. And for question C, to 2 significant figures. We take down question 5. Question 5, it says evaluate the following leaving your answer in standard form. For E, we have 2.9 times 10 to the power 6, all this plus 3.8 times 10 to the power 5. For B, we have 1.75 times 10 to the power 9, all this minus 1.25 times 10 to the power 9. These are the exercises for application on standard forms. In our next video, we are going to start by correcting the following exercises for application. If in case you have any questions, feel free to drop your questions at the comment section. Please like the video, share, and subscribe to this channel. Thank you very much for watching.